I'm filming!
The energy that gave birth to every living thing we know. Will one day become unbearable. This is Earth's future. Our sun, the giver of life, will eventually die. But how long do we really have? When exactly will it run out of fuel? And what will that mean for us? And for everything we've ever known? Welcome to Beyond World. Over the past 3 months, we've worked alongside world-leading scientists, astrophotographers, and VFX artists to reveal the sun as you've never seen it before. This is not just a documentary. It's a journey through groundbreaking science, breathtaking visuals, and the profound story of our star, from its violent birth to its inevitable dramatic end. The sun powers life. It shapes climates. It drives evolution itself. To understand its fate, we must first rewind the clock, all the way back to its origin. Picture the Milky Way galaxy, 4.6 billion years ago. Long before the sun existed, the galaxy was a swirling sea of gas and dust. Suspended by gravity, deep within one of its spiral arms, a cold, dense cloud slowly began to collapse inward. Gravity pulled the gas and dust tighter together, heating it, building pressure inside its core. Eventually, the temperature rose so high that hydrogen atoms, usually repelling each other, fused together, forming helium. That unleashed a staggering amount of energy in an instant. This process, called nuclear fusion, ignited the sun. In a brilliant flash, gravity had turned cosmic chaos into radiant light. But how do we know this story? We see the sun every day, but have you ever really wondered, what does it actually look like up close? If we could somehow shield our eyes from its blinding brightness, it wouldn't look like the familiar yellow circle in the sky. What you're seeing here is ultraviolet imaging, revealing intense electromagnetic activity invisible to our eyes. Massive arcs of plasma, explosions of energy, and twisting magnetic fields create a hidden world beneath its glare. But if that's not what the sun really looks like to human eyes, what would it actually look like, up close? The truth is, things aren't always what they seem. Sometimes, we need a new perspective to truly see the bigger picture. And that applies not just to stars, but to ourselves too. Talking to a therapist can help you uncover hidden patterns in life and relationships, just like we're uncovering hidden patterns in the sun. Back to the sun. If you could somehow strip away its glare, you'd discover something far more intricate, more alive, and more powerful than most people ever imagine. The sun isn't just a ball of fire, it's a layered, dynamic machine. The sun's outer atmosphere, a vast halo of superheated plasma stretching millions of kilometers into space. Invisible to the naked eye, it becomes visible during a total solar eclipse as a ghostly white glow. But thanks to special instruments that capture ultraviolet and X-rays, scientists can observe it in full detail, witnessing loops of charged particles twisting along magnetic field lines. This is also where we see solar flares, immense outbursts of energy that can affect the entire solar system. In 2018, NASA launched the Parker Solar Probe, the first spacecraft to touch the sun. Dr. Nola Fox from NASA explains, "For decades, we've wanted to get this close to truly understand how our star works. Parker is finally doing it." In December 2024, Parker became the fastest human-made object ever, flying at over 430,000 miles per hour, and coming just 3.8 million miles from the sun's surface. Imagine the sun is a basketball. Parker flew just 5 inches above it. One of its missions? To solve the mystery of why the corona is millions of degrees hotter than the surface below. Lying beneath the corona, this reddish layer is visible only through special filters. Here, plasma jets called spicules shoot upward, fueling the outer atmosphere's intense activity. Astrophotographers like Simon Tang, known as the stupid astronomer, capture these mesmerizing features, showing the sun in stunning new detail. Finally, we reach the sun's surface, the photosphere. Thanks to the Daniel K. Inouye Solar Telescope in Hawaii, the largest solar telescope on Earth, we now have detailed images of this roiling surface. It's not calm, it's a boiling sea of plasma. Massive convection cells, some larger than entire continents, form and vanish within minutes. It's like a pot of hot oil, bubbling and churning, but on an unimaginable scale. And then there are sunspots, dark, cooler regions where magnetic fields disrupt the surface, often marking periods of intense solar activity. These sunspots follow an 11-year cycle, peaking during the solar maximum, bringing stronger solar storms and flares. The sun won't burn forever. Like all stars, it has a life cycle determined by its mass. Our sun is a main sequence star. Steady and average in size, it burns hydrogen for about 10 billion years. Right now, it's middle-aged, roughly halfway through its lifespan. Smaller stars, called red dwarfs, can burn slowly for trillions of years. But massive stars live fast and die young, burning out in just a few million years in violent supernovae. Supernovae may seem catastrophic, but they're also essential. They forge heavy elements like carbon, oxygen, and iron, the very elements that make life possible. Without supernovae, the universe would remain a dull mix of hydrogen and helium. The calcium in your bones, the iron in your blood, all of it was forged inside stars and scattered across space by these titanic explosions. As Carl Sagan once said, "We are made of star stuff." Despite its life-giving warmth, the sun also poses serious risks. Its solar wind, a constant stream of charged particles, can trigger beautiful auroras, but also threatens our satellites and power grids. The greatest danger comes from coronal mass ejections, CMEs, massive plasma eruptions that can disrupt technology worldwide. In 2012, we narrowly missed a CME that could have crippled modern infrastructure. In 1859, the Carrington event caused telegraph systems to fail and auroras to appear as far south as the Caribbean. Today, we're more vulnerable than ever. Imagine waking up with no GPS, no internet, no power. NASA's Sunrise mission, using tiny CubeSats, is building an early warning system to track solar storms and protect our technology. But what about the long-term future? As the sun slowly grows brighter over the next billion years, it will intensify Earth's water cycle, triggering massive weathering that pulls CO2 from the atmosphere. Eventually, this process will strip away carbon dioxide, causing plants to die, ecosystems to collapse, and oceans to evaporate. In around 5 billion years, the sun will become a red giant, swelling to engulf Mercury, Venus, and possibly Earth itself. Everything we've ever known, every building, every memory, will be vaporized, becoming part of the sun's dying remains. But this isn't the end of the story. In time, the sun will shed its outer layers, leaving behind a glowing white dwarf, its core. The material it releases will drift through space, seeding new stars, new planets, and perhaps even new forms of life. Our sun's death is part of the cosmic cycle, a process that creates, destroys, and creates again. Even now, scientists are finding ways to use natural processes to fight climate change, including enhanced weathering, which mimics Earth's natural rock cycles to capture CO2 far faster than usual. By spreading crushed basalt, researchers can accelerate this process, potentially locking away carbon and mitigating climate change. It's a reminder that while we cannot change the sun's fate, we can influence our own. Solar power, space research, and climate solutions all stem from our deep connection to this star. In the grand timeline of the universe, humanity is just a fleeting moment. But in this brief moment, we've harnessed the sun's power to transform our world. The sun is far more than a giant ball of gas. It's a symbol of creation, destruction, and renewal. It has been worshipped as a god across cultures, and in many ways, it deserves that reverence. It gives, it takes, and it will outlast us all. Yet, when it finally fades, it will leave behind the seeds for something new. Next time you feel its warmth, take a moment. Think about everything it's done, and everything it will do. You're not just standing under a star. You're standing beneath the most ancient, powerful force in your life. This is your brief moment under the sun. Let's make it count, not just for ourselves, but for all the generations yet to come. And speaking of untapped energy, beneath our feet lies another ancient force, one that could change the future of energy forever. How could drilling into volcanoes unlock limitless clean energy? And what dangers might lie beneath? Join us next time as we journey deep into the Earth's core. If you found this fascinating, please like, subscribe, and share this journey.